Board. And we're going. Okay. Hey, everyone. If you're listening to this, that means we published it on the Reason Town channel. And this is Murphy Randall with Sean Grove.
Hey, thanks for having me.
And we're just going to try to hack a little bit on the Reason language server. Sean, have you ever done work on this before?
I have. Jared was kind enough to sit down with me last time I was out here. We hacked on it a bit.
Oh, great. Well, then you've had 100% more training from Jared on this than I have. But I've been hacking on it for the last 3 or 4 days. We started on Friday. My coworker Haas and I just started doing some hacking on it. And I've been surprised by the number of things we've been able to do. So I've got 2 PRs up right now with 4 additional features. So that's been really fun. And now I'm working on a 5th feature. So I thought it would be fun to see if we could get autocomplete going for objects, for JS objects. I guess it would be OCaml objects as well, but especially the JS objects. So here's where we are. You can tell me if you think we're in the right place. I've got one tab open here, or one VS Code window open that's got the source for the language server in it, and another window with my sample project in it. And they're both pointing to my development copy of the server. And okay, so here's what I got. My sample file, I've got a record that's type called Bob. Actually, Bob, I have a record type that's called Bob2. And so that does support autocomplete. And then I've got an object type that's Bob, and it's got a field Sal, and this does not support autocomplete. So I've got some logs coming out of the server right here that show me that when I try to trigger autocomplete right here on a field with a hash, hit control space, and it says nothing completable found. So in other words, the partial parser isn't finding anything that it thinks it can complete. So I'm guessing the first step is to go into the partial parser. Actually, let's go into message handlers. We know that we're not getting into this function, which is the text document / completion message handler. We're getting in here. It's calling partial parser.find completable, and we are not getting into any branch except for the nothing branch. So
before you dive in here, I just want to check for the other screencast. Have you done another screencast where you showed implementing the autocomplete for the record?
No, because I haven't dug into that myself. I thought that would be one thing we could do.
Yeah, maybe we could take a look at how that's done and just get a sense of like, how does the Reason language server know what is actually autocompletable from any given part? And then we could see if there's an analogous thing that we can do with the objects.
So let's actually start from the very beginning. If someone's watching this for the first time, basically we have a JSON RPC server here that receives requests to endpoints that are defined by strings, and it sends in JSON and expects JSON out. And that's our context here. So the editor sends text document / completion with some params saying, I want you to complete this position in the document. We get the text of the document, the text of the file, and the offset of the cursor. And then we go ahead and we try to, based on that information, parse the document to find something that we can complete. So inside of find completable, I'm guessing this is where we're going to look to see if we can find a record, for example, right?
That seems about right.
So what it's going to do is it's going to go through this loop, and it's going to start at the cursor, and it's going to start backing up. And if it finds a dot or an underscore or a number or an alphanumeric character, it'll keep backing up. And if it finds, this is always a challenge to read for me. There's some point at which it starts recording the things that it's backing up over. So I would have expected to see a brace in here, right? To say, oh, I'm inside of a record and I can complete that. Find completable text.
Can you show us can you show us an example of what it looks like whenever you're actually auto-completing a record?
Yeah. So here we are. Here's the record type Bob2 with a field Sal, and there is a record defined. That doesn't matter though. And then I'm doing a js.log statement. I type, oh, there's a dot. That's why I type Bob2, and then I hit a dot, and it pops up.
Okay, so
the field Sal.
If you were to create another record, though, would it autocomplete the SAL for you?
If I were to create another record?
Yeah, so see how on line 10 you have Bob2 is a record with a key of Sal?
Yeah.
If you just delete the contents and you type S, does it autocomplete for you?
It does, indeed.
It does. And is that coming from the Reason language server?
Yes, that is.
Okay, so it looks like it would need to back up to either a period, as in your first example, or to an open bracket, as in this example.
Totally right. So there are two different autocompletes then we want to support, right? One is autocomplete of like the fields when you're making an object literal, and then there's the autocomplete of accessing an object, right?
Yeah, exactly.
So I was going for accessing, but I'd like to do both. Which one do you think we should do first?
I'm actually a little bit unclear on how we're going to know what to autocomplete, because the object system is much more flexible than records, right?
Yeah.
You can just throw any field on there and it's cool.
Right.
So I'm curious how we'll know what are the options to autocomplete at that given point.
That's a great question. Maybe there's not even something in place to do that, right? Because here, yeah, like you're saying, how do we know that how does Bob2 know that we are interested in auto-completing a field named Sal, right?
Yeah.
And that's interesting because if we put nothing in there, if we put no field letter at all and we ask for a completion, it doesn't know that it can complete it. We have to put a letter in there first.
What if you were to add a type annotation to on line 11 and say that this is a type of Bob2, and then see if the autocomplete does anything? Yeah.
It doesn't support it.
That's why I'm unclear if the autocomplete is actually happening from Reason Language Server, like inside of this. For the dot, almost certainly. You know, for the record access, almost certainly. But for filling out the fields, maybe not.
So for filling out the fields, if we say S, and then it says type Sal, I'm pretty sure this is coming from Reason Language Server, but we can double check by going inside of message handlers. Are you gonna get down? Okay, then you have to sit here and be quiet. Okay, so we can log out right here. So let's say log AAAs. I'm grepping for a AAA in my logs to kind of get out the cruft. So let's go see if we get some completion inside of this handler here. So I saved the file. The Reason Language Server should be recompiling. There we go. It's reloaded in our browser or in our editor. So here I type S, and we can see that it's completed. S.
Very cool.
So I guess somehow, once I type a field name, I'm betting what it's doing is looking for all the opens and looking for any defined records and looking for any fields that start with that letter and offering to autocomplete those. Because let's do a different type here and name it like, oh, sorry. Let's copy Bob2 and name it Jenny2. I don't know. I'm just coming up with weird names. Okay. And then let's give it a field Sully instead of Sal. And so now when we autocomplete, I'm guessing that both Sal and Sully are going to pop up because we don't know the type, right? No, only Sal pops up.
We did force it to be Bob2, yeah.
Okay, so let's delete the type annotation. Nothing shows up with no letters, but if I hit S, I get, interesting, I lose all of my type recommendations.
Well, this one hasn't compiled yet because of line 18 probably. And line 17 are not correct. True. So we might have to compile it out and comment out line 15 so that it actually successfully compiles. That new type Jenny2 will be available. And now if we try to autocomplete.
How interesting. Okay. So only Sal pops up as a recommendation at the top and then Sully pops up at the bottom. That is so interesting. But okay, yes, as we were saying, when a record doesn't have a type suggested, only one field shows up. Now, if we specify this as Bob2, and then we hit S, does it suggest Sully? Yes, it still does. So it looks like the autocomplete for records is just finding all the fields in whatever is in scope and suggesting that I complete those.
Okay. I mean, that seems like a reasonable heuristic. That's not too bad.
Yeah, it could be a lot worse. Sometimes it gets confusing because you're like, oh, I can add this field to the thing because you see it in your autocomplete, but you actually can't.
That's a good point.
But I think it would be significantly more complex to actually determine the type at, well, I don't know. There is code in here to get the type at the current cursor, but I don't know if you could get the type of like the record literal construct at the current cursor.
Yeah, that might be, I mean, it might work. But it might be also challenging. I feel like whatever we're doing here, it might be challenging, but maybe that's the fun. So,
sure. Well, let's try this. Let's go for the less challenging one that's still a win, which is auto completion on objects, right? which doesn't work at all. So sorry, not autocompletion on objects, autocompletion on accessor for objects. That should be not as hard, right? Because you know the type of the object.
Well, I mean, kind of, right? Yeah, I guess you've given a name to your type of Bob, right? So
even if we haven't, I know that the type system can track the shape of an object as long as it's not open. As long as it's not, rather, as long as the object hasn't been like made completely dynamic by an object.assign call or something like that.
Okay, that sounds good. All right, so we should know then what the methods and the fields are available right here is what you're saying, right?
I think so, but let's see if that's built into the language server. Because if it's not, then we're hosed because I don't know those layers well enough. And hopefully you might, but I don't know.
I absolutely do not.
Okay, great.
I sat down with Jared, but I've forgotten everything. So
I know that he has code in here that reads the CMT files, which I learned from Antron today, are files that are intermediate representations from the compiler. I know you already know this, Sean, but I'm telling listeners that those files represent code that has been compiled, and it's type level, basically like type level cached information. So if you read the CMT file, you can get information about types at certain places in the code or in certain places in the AST. Is that right?
Yeah, that's actually why it's important to get a successful compile for the autocomplete first.
Yeah.
Because if you've added types, but it hasn't actually successfully compiled since you added a new type, the CMT and the CM whatever files won't actually have been updated. And so RLS will still be working with the old information.
That makes total sense. And I hadn't even realized that I could just comment out files, get it to compile that way, meaning by just letting the editor evaluate a valid file, then I could get a successful compile. That makes a lot
exactly.
Tips and tricks for people who are, I guess, writing Reason are things that I didn't know about before hacking on the server, like that. Like, let's get the file to compile and then we'll get help. Or like, let's even just hit control space at certain areas and I might get completion information that I didn't have otherwise. Those things are all helpful. Okay, so, let's just see if we could get this for free somehow by, if we go into our parser, the partial parser, and we say find completable, and we just add hash support in here. Do you think would we get lucky? I doubt it, but we might. So now that says that if we encounter a hash character, that's kind of like a dot, and we should be able to extract the identifier following that hash. Is
that we might need to do a different offset, I guess, right? Because the identifier will be like hash something, because it's hash, right?
Unless it backs up to the first hash, right?
Okay.
It may never find that second hash because it's backing up from the cursor position. So it'll probably find that first hash and then track forward. But let's see what actually happens. Okay, so we do already have a log in there to, okay, look at that, interesting. Completing hash for string, Bob hash. So you're right, it did include the double hash at the end. But in that case, let's see. Finding something completable. So this is interesting because at the end we say, okay, otherwise it goes forward until it backs up, I think, until it loops I-1. If it finds a hash, I think it starts. Oh, that's what it is. No, you're right. If it finds a hash, it starts capturing and it moves backward until it reaches some non-identifier. So I had it backwards in my head. So
I think we need to probably kind of special case the hash, just like the tilde is special case for the labeled argument.
Yeah. Let's see. So if we do the tilde here, okay. So you're saying if we reach a hash, instead of doing this, we take the tilde. The difference is that the tilde prefixes and the hash postfixes, right?
Yeah. And what we're trying to do is grab Bob in this case, right? And then ask what is the type of Bob? It's an object, and see if we can get a list of the fields from that. Is that right?
Yeah. And the other parts, I'm hoping that maybe the other parts already work, because there already is code in place that takes the position in the file, goes and reads the CMT, the type level information, and from the type level information extracts the type. And then we might have to figure out how to get fields from there, etc.
Okay, one thing that you could do then as a hack, and just maybe leave a comment to come back and fix it, is so you have like the final thing that returns. So in this case, it's Bob hash hash. Just check to see, does it end in hash hash? If so, remove the hash hash and we'll just get Bob.
That's exactly what I was thinking too. So we say if, okay, so let's change this to be a little more verbose. If offset is equal to -1, then return nothing. This formatting is difficult to work with sometimes.
I don't think Jared uses reformat in here, does he?
No, he doesn't. And I kind of understand why, because there have been a couple times when I've actually run refummed on the file and it makes it look much less readable, unfortunately. Okay, so here we go. So let's say that here's where we're going to extract the long identifier. Let lident string equals, and the long identifier is, for those who are listening, it's basically just like the name of the variable, essentially, that we're working with. So there's the lident right there, and we say lident string, and then maybe we say like if lident string dot or utils is a module that he has in here, and it won't autocomplete for some reason. Unfortunately, it's what we're working on. I find some weird bugs with the native stuff because it's like it won't autocomplete between modules sometimes, like between native packages. But I haven't been able to pin that down yet. So ends with utils dot ends with string suffix. So utils dot ends with hash hash. So if it ends with hash hash, then how do you feel about shadowing?
Oh, that's fine.
You okay with it? So if we did like lident string and reassign it, lident string equals lident string into string dot slice, I think it is. String dot
substring, maybe? Yeah, I mean, you have string dot sub there.
Do I elsewhere in the file? I do. Yes, I do. You're right. String dot sub from 0 to lident string dot length -2, right? Or should it be -3 if we're cutting 2 characters off the end?
Yeah, we can start with 2.
Okay.
The only thing is the shadowing won't work in this case because you have 2 different scopes effectively there.
Oh, poop. You're right.
I mean, what you can do is just an
expression in here.
Yeah.
A ternary.
Or a switch, yeah. I'm not a huge ternary person.
Okay, so I would do switch for doing it in your style.
Yeah.
Sometimes I like the old ternaries.
And if it's false, then it just is lident.
Lident string, right?
Mm-hmm.
Oops. Now, I wonder what's wrong with that. Format selection.
Yeah, so if you format the switch with the true first, then it will turn into ternary anyway.
I didn't know that.
Yeah.
I mean, I didn't know it mattered about the order.
Well, I mean, in the AST, they're exactly the same.
Okay. Why does it say that lident string is not an instance variable?
Oh, because you have to do another let. So what you're doing right now is trying to, like, unmute. Yeah.
I'm doing dumb things in my head. That's what I'm doing.
No.
I mean, like, I'm programming like I don't usually program because we're being recorded.
I see.
And because I'm so nervous to be working with the amazing Sean.
Well, yes.
So amazing. Okay, so does this look, maybe we should leave a comment that says like this is a special case for objects.
Yeah. I mean, this would probably clean this up later.
Let's do it. Great. And let's see if we can format this whole branch better. Probably not, because that's not valid partial syntax. Okay. Why does that look weird? Because that's probably why. It's like, I don't love it, but that looks okay, right? Is that readable to you?
Yeah, I mean, it's fine for me, as long as the syntax is okay.
Okay, so what we did is we just pulled out a lident. Now, another thing we could do is like special case. In fact, what we could do here is instead of returning lident string, we could say like this. And instead of a long identifier, we could say like object field if we need to treat it differently.
Yeah.
So maybe let's see if we need to treat it differently after the fact. Let's see if it just works. That would be amazing. Okay, I'm waiting for it to recompile. Maybe it's not going to because I've already recompiled. Completing for string Bob hash hash. It looks like it has not recompiled yet. So
yeah, was there a syntax error? Is that way to tell?
There was not a syntax error because it ran. Now sometimes it gets into this weird state where I have to actually like unlink the executable and relink it again, because maybe there's some weird caching that goes on. We start language server. Okay, they're like, hey, it's gone. And then if I link it again, maybe that'll fix it. Because we should be getting updated text now. Unless did we program it incorrectly somehow?
Well, are we sure that it's even in here? I mean, we're several like tests in, right?
Yeah. We know that, okay, yeah, so then let's go ahead and check, I guess. So we could say log.log got in the place. And we'll throw in some A's on there. And that way we should know. Okay, okay, it did restart, so that's great. Great,
yeah.
Got into place. Now, is our substring wrong? Like, is our ends with test incorrect? I thought I got them in the right order. It should be the string first and then the suffix, right?
Mm-hmm. That looks right. I mean, we can just extract these to a couple of variables, right? So that lident utils end with, we can just say is object prefix and then log the is object prefix.
In here, you want to do that?
Oh, no, inside of the
right
place.
Here.
Yeah.
I understand what you're saying. Yeah. Okay, great. Let is object prefix equals boop, boom. Switch is object prefix. Now, why is that getting? Oh, it's because it's lident string, right?
Yeah.
So we can make yet another block. There we go. I love impromptu blocks like that in Reason.
It is nice, yeah. I thought that came from JavaScript, and I tried to do it in JavaScript, and apparently it doesn't actually work like that in JavaScript.
I feel like I've been able to do it a couple times, like in some places in JavaScript,
I see.
but not reliably.
Let's move the log line down to after that is object prefix and log that out so we can actually see.
Super duper. So log.log got in the place. And then now, can you teach me how to use string format? Because I don't really know.
Yeah. If it's in here, it's amazing. It's just format, so capital format. Yep. .sprintf.
I don't think we have format in here, but we do have sprint. We do have printf. What? It's not auto-completing for me anymore. Okay, let's just try it. Format.sprintf.
Yeah. And then it's just a string.
Okay.
And it's similar to the template string, except yeah. So AAA, and then any like type variables you put in here. So like %d means I want to put a integer in here. That's and right. %b means I want to put a Boolean in here.
And then it won't type check unless I do it, right?
Exactly.
Is that just like a compiler level thing or macro that they built in?
It's a completely insane GADT thing with a bunch of runtime stuff. it's insane. It's like even people who work on the compiler, no one wants to go in there and touch that. But a cool, like one thing I learned is that the format module, like that format sprintf, is expecting a certain kind of string. So I don't know if you can get the, if you hover over sprintf.
Yeah, it's a format string, right?
Yeah, it turns out that's actually just a string. And you can just tell the compiler, I want to use this as a format string. Because what happens is sometimes you want like someone else to be able to pass in a message to you, like a format string into you.
Yeah.
And you can't do that usually because like you have to type in the format string directly in order for the compiler to know that, this is a format string.
Right.
But if you just add a type annotation, like if you make that a variable, say, hey, this is a format string, then it will let other people like pass it in.
How interesting. Cool. That's really cool. Now, I know that I was reading earlier that if you do %a, you can provide your own formatters if it's an object. But
exactly.
That's a pain to do as well, right?
It is. Most libraries will come with their own, though. Like they're the .pp method. So like in CoHTTP, you have like CoHTTP headers. And it has like a CoHTTP.header.pp. Okay. And that's the thing that you would use with the %a. And it's basically like, here's a pretty printer that they provided for you. And
you have to pass it in. So you'd pass the object into the pretty printer.
So if you do like %a right now.
Okay.
Then is object prefix before that, you would have a like your custom pretty printer, comma, and then the object you want to pretty print. So a turns into like 2 arguments.
Interesting. And they're order dependent.
Yeah.
So it'd be like pp bool or whatever.
Exactly.
Even though it's not a real thing. Wow, interesting. Working with like the older OCaml ecosystem feels very strange to me because it feels kind of old. Like it feels like it was, the APIs feel like they were designed when I was in college.
It's an interesting idea though. Like how would you do, I mean, we don't have to get sidetracked with this, but like how would you like, what would a modern printer look like?
That's a great question. But I feel like there are some things I didn't expect. Like I would have expected maybe a tuple of the printer and the value or something like that.
That would be nice. But I think it's because of the GADTs that it needs to be this other style.
Okay. The other thing that really weirded me out was when I was working with regexes, and it's like the regex engine, it keeps around global state. So
oh yeah, no, don't get me started. Native regex stuff in OCaml is rough.
Well, I was using it yesterday and it worked out pretty well, but I was like, holy cow, it's keeping state between my last line and my next line, which does not feel OCaml-ish to me, or at least it doesn't feel reason functional-ish at all.
Yeah, I definitely think that one is very old, and I don't think anyone is super proud to have that in the standard library anymore. It's very hard to remove that kind of thing.
Well, it worked pretty well for me, so I'll keep it for now. But maybe that's why Jared didn't do any regex stuff so far, because I mostly found pattern matching from him and character traversal. Okay.
It's especially dangerous if you're using any sort of asynchronous stuff, right? Because of that global state. If you happen to call another function, you don't know what might happen to that global state.
That's scary.
Yeah.
So if you were going to use regexes, you would use some third-party library?
Yeah, I think RE2 is pretty good. It implements like PCRE and Emacs regexes and all sorts of nice things.
I know there's also a PPX regex.
Oh, I didn't know that. That's cool.
That might be interesting to figure out too. But okay, so here we go. We have a thing, and it says it is an object prefix. So it says Wahoo true down here, and then
I think we swept the order of the line. So 200 is false and should be true.
Aha.
Yeah.
Oh duh. Okay, great. So now
it was a long detour for that.
Yeah, that was, but it was an educational detour. Hey, look at that.
Wow.
It's not what we want, but it's there, right? That's interesting.
Well, and it knows that it's an object, right? So it has like the type Bob is a JST of Sal string.
But you know what it thinks? Look at this. Okay. Sal. It thinks, since we stripped off those hashes, it thinks that I'm trying to autocomplete the field Bob. Like the name Bob. It thinks that I'm doing this. So yes, what we definitely need to do then is we need to say we're completing a field here. So if this is an object prefix, then we need to say that we are not returning a lident, but we can make up a new thing, right? Object field. And then out here we unwrap the lident. And this is no longer a lident string, but this is the, what type are these? We'll have to figure it out. That's a foo. And then we're going to return foo. And then this is going to be lident. Yeah, there we go. Okay, so where does lident come from? It's a completable. So we can add on to here an object field. Object field string. Okay, I think this is going to help us out significantly.
Okay.
So now we should get out an object field, and then inside of message handlers, we get to add a case for object fields. Ooh, look at that bright orange text telling us that we're missing the object field completion. So let's copy labeled and see if we can emulate basically labeled behavior. Object field. Okay. So get arguments for position is a function that we factored out that gets the current location and goes and finds the function arguments that are being passed to the or that belong to the function that the cursor is currently over. That's obviously not what we need. But if we can find the code that autocompletes for a record, then we can probably do it. Like the record fields.
I'm very curious to see that. Yeah.
Get best definitions, new completions.get. Maybe this has something to do with it. Okay, so we're inside of new completions.get. I think this is a pretty complex function. Log.log opens folks string of int. Cat raw opens. So I think that's giving us what the opens are. And query file env full file. This is getting the information. This is getting a query env for the file that we're in. And a query env, I think, is basically just like the query type has this environment idea where it says, oh, you're doing a query and here's the environment that you have. Like here are all the things that are available, the exports and things like that. So in fact, if you go into a file env, you don't know these at all, right?
No.
Okay. So if we're going to open up query, do you see how I couldn't command click on the field? Because it tried to take me to the CMI or something like that. Yeah. This is fine.
Yeah.
So we have to go using the old command P. Okay, so a query env has a file in it and then exported, things that are exported. That file is of type file, and that's from shared types. So shared types has a type file, which has got a URI, docstring, stamps, and I think stamps are like integer representation of things in the file. Module name and contents, and the contents, where's contents? Contents has exported and top level things, a list of declared item, and a declared item has a name, location, stamp, module path, exported. Man, see, this is starting to get a little intense here. So there are a bunch of, inside of query, there are a bunch of like hash tables for values. And I wonder if there's one for types. Resolve path, find in module, resolve path, resolve from stamps, find compiler path, declared for, get attribute. That seems like it could be promising. Record labels.
Yeah, it does.
Okay, so maybe we should add some logging in here and see what we get. Hash find. But these files are where I start to go a little crazy because I'm like, I don't know what file stamps are.
Yeah.
Content.
Oh, I mean, if we log them out, I'm sure we can eventually figure it out.
Well, I know that stamp is an integer. And so I was doing some logging before, and it's like, okay, well, we get a stamp from something, but maybe that has to do with this, the CMI or the CMT. Like,
Yeah, I think so. So yeah, I think every so I'm not totally sure, but I believe that every type ends up getting like represented by some unique integer at compile time inside of the CMT, and it's like what is globally referenced as.
Okay.
And so the idea is you're really looking up like the stamp of an identifier of a type somewhere, and you're saying, hey, wherever this, like, I have this ID, go look it up in the registry wherever it exists, and giving back the information about it.
Okay, great.
I could be wrong though.
No, I think that sounds right. So I'm betting this shared types.file does not have a pretty print on it. So we're gonna have to do, I actually added the PPX deriving show into here. So
nice.
We could do like this, at deriving show, and we could say that stamps are at opaque, I believe. I don't know, have you ever used this PPX before?
No.
Module name at opaque. So that should give us a general idea of what this file looks like. So instead of using, actually, sprintf, we could do %s. So we could say the file is %s, if I can type % somewhere. And we say file, and we pass that into shared types dot show file. Now let's see, unbound module shared types show file. I'm wondering if that's just because of a bad cache or something like that, because this has worked for me in the past. Oh, you know what? I have to add the PPX to core as well. I added it to the two other libraries. So I'm going to go to core/dune, and in my PPX flags, in the preprocess flags, I'm going to add PPX deriving.show, and then under libraries, I'm going to add PPX deriving.runtime, and that should fix it for us.
Good memory on that.
Thanks. I've done it like 2 times in the last couple days. So easy. Hey.
Nice.
That worked.
Yeah. I mean, it may crash at runtime with, looks like adding in that one variant type. There are a few other places we need to maybe handle it.
Yes,
but,
that's right.
Give it a shot.
Okay, so let's get the stamp in there. %s, or %, the stamp is going to be a D, right?
Yep.
D, the stamp, and then the name. The name is of type what? Oh, great. It's of type A. That's not, how do we know what the type the name is?
I think it must be a string, because if you look down where label.name.text equals name on 220.
On 220.
So where name is actually used, it looks like it's compared to a text.
Yeah, that sounds right to me. Unless, yeah, that would make sense. Okay, so let's say %s name equals. Okay, so now we've got that in place, and it's compiling. There, it's compiling. Sometimes it takes a bit though.
Okay.
Okay, so we should see some log output here, right? Completing for string dot sal. I'm surprised that it's not showing us logs out here.
Yeah, I guess it should, right? Yeah, for the record.
If we're using get attribute.
Yeah. If you see, like, what does this actually come back with?
What does it return?
Yeah, there's some like option of a label, right?
Option of shared types dot type dot attribute dot t.
And is it get attributes or get attribute that we were on? Yeah, get attribute.
Singular, yeah.
Yeah, so it looks like maybe this is when you're specifically looking. So maybe the name here is the name of the attribute we're trying to look up on the stamp, which is the identifier of the type.
Right.
And so, yeah, it's not clear to me. Is get attribute, where is that actually called?
Right. We should have searched that first. Should we look for that, or should we just look at what else we have around?
Maybe if we go back to where we're handling the message,
Okay.
and for the autocomplete, and we see like we can follow that tree of like what is it calling into.
Here goes.
For records. Yeah.
Here goes. Yeah. So this is what I'm guessing it's inside of this huge function, which is new completions.get.
Okay.
Should we look for record maybe? See if it says anywhere. Oh, look at that.
Yeah. And then there's a list of record or attributes.
Determine completion multiple, normal or attribute. Attribute target suffix, looking for binary.
Yeah, this looks great.
Record. Ooh, what did I just do? I don't even know where it went. Record. There we go. That's where we were. Okay, so let's say, should we log in here? Log.log.
Yeah, actually, maybe after this let opt here.
You want to do after the opt?
Yeah, I would like to get a list of. Oh no, I guess we have attributes right there. Yeah, that's fine. So
let's see if our show plugin helps us out. A attributes equals attributes, and then we'll pass it into, wasn't it type.attribute, shared types.type.attribute? Oh no, which one am I doing? Attribute.t, that's probably what it is.
Yeah, that looks reasonable. There's a name, location.
Flexible type, location. Okay, so a location is a built-in type that we can't add show to, so we have to say add opaque on that. Type, flexible type, I think we can deal with, and I think we can do location as well. We just have to go to them. Loc. No? Type loc. Location. No, maybe not.
Yeah, it's hard to know what Jared might have added on his own here, but location is usually a thing that's built into like the compiler libs.
He has, I know he has two. There's location, which is built in, which is like the OCaml location, and then there's loc with an uppercase L or a lowercase l, which is like a location in your source file that's meant for our own deriving. And he mentioned that in one of his videos, and he's like, oh, maybe there's a better name for this. I don't know. Okay, so let's go to flexible type though. Type, flexible type. There we go. Add deriving show. Oh, look at all those functions.
String, that might be nice.
What'd you say?
There's a toString that we could maybe just call on.
Yeah. Now, can you provide a custom function to @deriving, I wonder? ppx deriving. Show. Okay, deriving show. It's possible to pass options to a plugin by appending a record to the plugin's name. Okay, let's go down to show, actually. Oh, maybe I should have looked at that working with existing types field right there. Okay. A lesser known OCaml feature allows to derive functions for any existing type. What? Using pervasives.fp class, show can be derived as follows. Okay, my brain is already melting. I don't understand what they're saying.
Yeah, let me see. So show my FP class readily accepts FP class, not just. So it looks like, yeah, I mean, this looks similar, right? Like what it's showing here, I think, is they're taking the built-in FP class where you have, or like type, sorry, FP class type, where you have like FP normal, subnormal, 0, infinite. and he's creating another module with his own type called myFP class, and just saying, hey, this is exactly the same, and derive show on this thing. And then, and
so he's saying, he's basically making an alias and deriving show on the alias.
Exactly, yeah. Although there's a PP import to automatically pull in the type definition, attributes can be attached using its with replace feature. I mean, it looks like there might be something cool there. I don't know. Usually PPX can't do too much because all a PPX is able to do is generate code. It can't really it reads your syntax and then generates code. So it can't say like, oh, what are the types of variants that you have, right? I'll automatically add annotations for them.
Right. Okay, that makes sense. So, I mean, I guess we could go and we could like alias loc and say my version of loc has deriving show on it, and maybe that would work. But the thing I want to do is have my own toString function, right?
Let's see.
Oh, it's like this. For an abstract type, show expects to find a ppty function in the corresponding module. A formatter type T has type formatter of T of unit. Okay, so at printer function format fprintf fumpt. So fumpt is the thing that's coming in.
Yeah, format is like the format's buffer or something that all the formatters seem to work off of. I don't know if it's a buffer, but they have like this one format thing you have to kind of pass around between all the format calls.
Okay, so flexible type.
But actually, what I was going to suggest is flexible type itself already has a toString method, so we can just pull the type out and just call toString on it.
That's exactly what I was trying to do. That's what I was hoping for. And it looks like it doesn't work. Oh, did I annotate it in the right place? I know this is...
It's okay. Well, you want to put it beforehand.
Before the field or before the value?
Actually, yeah, that looks like the right place.
Yeah, that doesn't look right.
Yeah.
Okay, so what did we do wrong here? Flexible type. Flexible type. That was right? It's a dot. It's not an object. We call toString and pass it unit, and we should get back a string.
Well, I think the printer in the example it showed was not returning a string anyway, right?
It was doing sprintf, right? Oh, it was doing fprintf.
Yeah, which prints into like one of the format things.
Yeah. So a formatter for type T has type formatter T unit. So
yeah. So I think we could go pretty deep on this and like try to figure out the like format module. I usually just use like sprintf and maybe asprintf if I'm feeling bold. Otherwise, I will just like for that log line, I'll just write out a manual couple like the fields I want to see. So we can just call like attribute dot flexible type or type dot toString.
You mean just where the attribute's coming in?
Yes, yeah, exactly. So if we remove all the deriving show from here, and then inside of new completions, we just in that log line call attribute dot tip dot toString.
Okay, that's a good idea. I feel like I spend so much time wanting to log stuff out, at least at the beginning here, that I was hoping to learn to make it easy to log things out. But that's pretty easy. The sprintf itself helps a lot. Except now we have a list of attributes, right? So we're also going to have, there's no like F format for a list. We have to map, right?
Yeah, there's no common list format like thing. It's not that powerful. But yeah, so just a list.map and then a string concat. That'll give you a, it'll convert a list into a string.
The string module has a concat on it that'll take a list?
It will take a list of strings. So we have to take the attributes, map over it, and get a list of strings.
So attributes into list.map, probably belt.list.map because it's order first. Belt.list.map, and then we take in attributes A, and then this is where we do format.fprint F. Actually, what we
No,
can.
no. Yeah, we can just do a.to string. A.tip to string.
Oh. Oh, yes. Okay. I gotcha. We won't get the stamp on there, but that's okay.
Exactly. I mean, until we have an idea of what the stamp is anyway, I think we're okay.
Yeah, okay, that makes sense. Okay, so now we got a list of strings, and so we could say string.concat.
Yeah, the only problem is that string concat wants the list as the last argument. It's t last. So we may not be able to do that fast pipe.
Isn't there just one argument? Oh, we got to concatenate with a thing, right?
Yeah, exactly.
Concatenate string, and so we could just say concat with like that.
Exactly,
and
yeah.
It wants to be last argument, and so we go like that.
Oh, cool. I didn't know that fastpipe could do that.
Surprise! It works.
Okay. And then inside of the format string, we don't want to do a plus plus. Oh, no, I guess, no, never mind. Yeah, we're not using format. That's fine.
We're just doing boring old stuff. Yeah. Okay, so ideally we would actually get something out here, right?
Yeah, assuming this is, we're going down the right path.
Completion. Yeah, nothing.
Yeah, so I think it's probably good that we didn't spend too much time trying to figure all that out.
Yeah, I think you're right. But wait, where were we? Because we were in some kind of, we weren't inside of this thing down here.
Mm-hmm.
So what's this? Attributes to? Any other records in here? Hey, look at that. Attributes to equals string.
Very cool.
So that's interesting. So now we're too deep in, right?
Yes, we're down there.
Like we've gotten further than we meant to.
Okay, well, can we go back? So it says attribute 2 is a string. Can we go back real quick to the usage? So the call site.
For
Bob
this,
2. For Bob 2.
For, oh yeah, sure.
And can we add another field that would be an integer?
Sean int.
Yeah. And now whenever we try to autocomplete S, like what do we get? Oh, yeah. Once we fix this.
I'm going to say Sean's number 1.
Ah, cool.
String int. Right?
Perfect. Yeah, great.
Interesting that we're just getting lists of types and not field names. I thought we would get field names as well.
We pulled out the a.tip and turned that to a string.
Correcto.
Yeah. If we did your full, turn it into the driving show, we would have seen everything.
And we would have gotten the attributes.
Yeah.
Okay, so that's great. So this means that at some point there has been a function that has identified the fact that we're inside of a record constructor, and it has given us back this record suggestion. So determine completion appears to be the thing that's doing that.
Yeah.
So instead of determine completion, here we have yet another wonderful loop from new completions. So that means what? So let's see if we can read this. So we loop 0 with items. Okay, what are the items that we pass in? Multiple. That's a list of string. Why don't we log that out? Logging is crazy. Oh, it's a list of string.
Yeah, so just the string.concat will be fine.
String.concat. I'm going to concat it with a crazy character for fun. Okay. Just to shake things up. That should work, right?
It has a list of yeah.
I think it's because of the order of operations on that plus plus. We got to use the fast pipe, and then we got to throw that in there.
Okay.
Dum, dum, dum. Okay, ready? It's exciting. Bob 2. And that's the only thing.
Okay. Okay, so it's able to go from this random string of Bob 2 to knowing that its type. Well, the other thing is, can we change the name of the type of Bob2 to like person?
Sure.
Because now our variable and the type are the same.
Yeah, why don't we get this, like a little bit more sensible? Surname and age. Then that'll help us figure things out a little better, right? So instead of Bob, we don't even need to make a field there. We just need to know. Actually, we probably do because Bob2 as a value has to compile.
Yeah.
So let Sean's surname is cool guy.
Perfect.
And your age is 9,000. Oh, age. I should have put the gray for like Gandalf the Grey because that would have been cool, but I didn't. Sorry, Sean.
It's all right. I'll survive somehow.
Okay, good. Okay, so now we're completing for Sean, right?
Yeah, and you can see that completion items, Sean.
So it's only really trying to complete Sean.
Okay, perfect. So it's able to go from the variable name to find its type, then to figure out what the attributes are. So it's doing a couple of hops here.
Which is pretty amazing. The thing I'm concerned with is that I don't see an object or, I don't see record anywhere. And I was expecting this to return a record, unless it's calling a function that returns a record somewhere.
Well, it might be interesting to, and like we already tried that it doesn't get down there if it's an object lookup, right?
Yeah, I'm too deep in now, yet again, because the record comes from type.contents.kind.
Mm-hmm.
That's the record that's the thing that's coming out as a record. So where we really are is inside of another switch, which is target, which is inside of attribute. So it's recognizing that we're inside of an attribute right now, right?
Yeah, maybe. What are the types of target and suffix?
List of string. Should we log them out?
Yeah, let's do that. Yeah, let's go ahead and log that out. And let's try autocomplete for both the records and the objects, and we can see what gets logged out.
Okay, let's see. Is this the right place to be doing it then?
Yeah, that's fine.
Okay, great. I was starting to write before you'd finished talking, so I wasn't listening very well. Target is %s, and the suffix equals %s. So, some things about OCaml have made me miss Haskell. Like I felt like the deriving show on Haskell was pretty hands off.
Yep. There is some work on that to have generic pretty printers, which would be. I actually think it takes away like most of people's desires for like modular implicits and higher kind of types. Really come from people trying to log stuff out most of the time.
That makes sense. One of the most basic and important things, and all the people who don't do strong type systems are like, what are you guys talking about?
Yeah, exactly.
It's just log stuff. Okay. Target string.concat with a thing, and then suffix. You know if format.sprintf, does that work in BuckleScript?
I think it should, but it brings in a pretty big overhead. It's like a couple hundred kilobytes, I think.
Oh, really?
Yeah. Which is surprising. I thought it would be an entirely compile time thing that would just compile it to a normal function, but it doesn't.
That's so interesting. It's got a runtime thing.
Yep.
Okay.
And what if you do s or Sean.s and then try to autocomplete that?
Yeah, great idea.
Suffix come out.
Yes, yes, okay. It does indeed. But that is not going to happen with Bob, is it? Yeah, it is not.
Okay, great. So that means we just need to figure out how to get the Bob ## into an attributes thing like the record.
Great. I'm gonna put another object in here so we have some testability. age. And Gandalf's going to be a little older than you are. I apologize.
That seems reasonable.
Type person obj, and that's going to be surname string and age int. Okay. So that's where we should have had something. Oh, there's no Bob. This is Gandalf. Yeah. Okay.
Okay, great.
Okay, you said something, and it was we're going to go over here and log something, right?
Yeah. So actually, before we log, let's look at this attribute and see where's that coming from in the switch.
That's determine completion. So this is where we need to add support for the hashes in here, I'm guessing, right?
Yeah. Let's see if first let's log in here. Just log the items before we get into our recursive loop.
Okay.
And see if we hitch this code path with the objects.
Item before loop, and that's going to be %s. Items, and items are what? That's a string. Great. That was easy.
No, probably not actually. If you comment out this line, it'll probably.
Oh, is the inference is killing it, right?
Yeah, exactly. Yeah.
Okay. Thank you. That's helpful.
No problem.
String dot. I was like, wow, that's too convenient. String dot concat, and we're gonna concat it with that and that. There we go. I'm not putting this on the podcast because no one's gonna tell what on earth we're talking about without visuals. Okay. So in this case. Oh, great. It crashed. What was that crashiness?
It probably got to like one of the cases with an object field that we didn't actually handle.
That's interesting. I wonder why I didn't do that before.
Yeah.
So message handlers line 91. So it's this one, and it's saying it doesn't. We covered all of the cases here, didn't we? This pattern match is not exhaustive. Object field. We are matching object field.
For the switch on 91.
Yep, that's indeed this one.
Switch for that. Nothing.
Should we clean and recompile?
Give it a try. I'm more inclined to believe that we're missing something.
Okay.
That is worth a try. In particular, I wonder if the PPI, the let try thing is doing something weird.
That's possible. I haven't experienced that before. This is Jared's precursor to let anything. So he wrote in the project. And I think what that does is that takes an option and it converts it to a result with a message. Or no, with no message. Okay, so the tests, okay, we're good now. The tests are non-exhaustive, but the actual content itself should be exhaustive. So we shouldn't get a crash here.
Okay.
Okay, no crash. No crashies. Okay, so, but also no loggies either.
Mm-hmm.
Oh, there we go. Okay. So I don't think we're getting these completions for string. So let's go into here. And we wouldn't be because we set up the code path to not go through the same place either. If you remember.
Yeah.
Okay, great.
All right, great. So we haven't even got into the determine type function or whatever the determine something function is.
Completing, yeah, because we don't say completing before string, do we? Oh, wait, this is the wrong place. New completions, determine completion, item before loop. We are getting in there.
We get in there for the record, not for Gandalf, not
Correct.
for the object.
Correct. And the reason that is because we made this other type, this object field type.
Mm-hmm.
So now I'm thinking, let's actually go back and undo what we did there and return a lident.
Yeah, I think that makes sense because like a lident is super generic, right? It's literally just like some identifier, a literal identifier. And so we don't need to tell it that, hey, this is an object identifier.
Hey, Lydia. Are those, oh, I love your shoes. I love how they match your dress. That looks great. You look so good. That is adorable, Lydia. Okay, so here's a question.
Mm-hmm.
I'm betting we should leave one of the hashes in there because remember when we pull out this js.log Sean on the record, I'm wondering if the partial parser leaves the hash in. And that's how it knows it's going to be completing an object, or the dot rather. Let's go see. Does that make sense what I was saying there?
Maybe. I don't think it leaves the dot. I don't remember seeing a dot anywhere in our logs, at least.
It does right there. Completing for string Sean dot.
Ah, okay.
So I'm betting we should just take one of the hashes off, or leave both of them on, right? Because if we leave both of them on, then we can have something to switch on. So let's go to that thing where we took out the hashes and put them back in again. And now I'm missing where it was. I think it's in the partial parser, right? Partial parser hash, yes, is object. This whole thing we don't need. All we need is the lident string.
Okay, yeah, give it a try.
Okay, so let's take this. Oh, those look so good, Esther. I love the blue. Did some of them come off in the bath? Oh no. I'm working right now. You can say hi to the people who are listening if you want. Oh. Just say hi. Else, she's waving hello to all those.
I see. Yeah, I was waiting for it, but
this is my daughter, Esther. Okay, so this is going to be a lident. He says hi too. All the people say hi. Okay, great. So that should compile, and now we should get some more interesting stuff out here as soon as it actually finishes compiling, but maybe it's broken. Yeah, look at that. Completable. Yeah. What did we do wrong?
I think we still have a reference to object field somewhere.
Oh yeah, almost certainly here because I probably didn't save. Okay, great. Great. Here we go. Completing for string Gandalf hash. Great. So then our next task is to get Gandalf hash into the same place where we're getting the dot, right?
Yep, that sounds right.
Awesome. We are making great progress here. Okay, so determine completion is too far in. We need to back up. It seems.
Yeah. Who calls determine completion?
Determine. Oof, I can't even search for it. Where is it? Determine yeah, it's not in this file because it's not going to be. It's going to be inside of new completions. Somehow I switched files. Oh, that happens to me too much. Okay. Determine completion gets called right here. So completion items, we're not getting to completion items either.
Mm-hmm.
Completing for multiple. Multiple is inside of a switch, and it will help me to start closing some of these things. Great. Locally defined values from opens. All right. So there's a switch for token parts. Those are a list of string. So let's see if we're even getting to token parts.
Yep.
format. Token parts are %s. And then we say, okay, I am going to pause this video. Okay, I think we're getting really close here though. So the token parts are token parts, and then we have to do our familiar old string.concat, that, and that. Okay.
Yep. And then probably prefix with a AAA.
Oh, so glad we're pair programming. Okay. Here goes. Token parts are Gandalf hash hash. Great. Okay. So I think that I am severely underusing pattern matching.
Yeah, actually, can we do the same thing with the records though, and just put autocomplete on the records? Yeah.
Token parts are Sean and.
All right, and some empty string. And what if you type A and try to autocomplete?
Sean and A.
Okay, and then even without the A, there's still a second thing in there.
Yes, so that's a significant difference, right?
Yeah.
So that means that something up here is splitting on something.
Yeah.
All modules, token parts, it's coming in from the outside. The call is coming from outside the house. So new completions.get. New completions.
And message handlers, yeah.
Okie doke. And parts.
Hey, look at that.
Hey. So this is a regex string. So we could do an either or here, right? Or hash hash. Let's see if that works. Could it be? Did we break this? Completion items, Sean dot, and yeah, we broke it, right?
I think so.
Yeah, we did. String. So why did the regular expression string work for dot? Because it should have been an escaped dot. Right? The dot means anything in the regex.
Yeah. Not sure.
Yeah, that's broken. That's straight up kooky dukes.
All right, so we try to bring it back to what it was, and just so I have a sense of like what it's supposed to be doing.
Yes. So it should be that we should have two items in the list, Sean and.
Okay, sounds good.
Sean and A, right? Oh, why didn't it work that time? Okay, yeah, Sean and A. Okay. But if we change this again, because this is just, oh, it's a regular expression that matches exactly S and nothing else. That's the problem. Okay, so if we did this instead, regexp / that or hash hash, I think that would work.
Yeah, and you're gonna have some problems with that / I think.
Because I have to double escape it.
Yeah. I always try this like 3 or 4 times, like triple escape, single escape, double, until it stops complaining.
And sometimes it's quadruple.
No, there you go.
Look at that. I think that worked.
Okay.
Now, did this work?
Hey.
And woo!
Great.
Okay.
And now we're in the loop as well.
That's great. Item before loop, Gandalf, and so now we can go back into completions. We know that we're in multiple, right?
Mm-hmm.
Completion items, Gandalf, and.
And I think it's
What?
Yeah, so inside of determine completion, I think that's where the items before loop uh, is, right?
We're actually getting out attribute here
Yeah.
because we're getting out target and suffix.
Oh, great. Yeah.
And so the real question is the type, right?
Mm-hmm.
Switch target none, first rest, looking for declared, query found in scope, stamps values, get constructor path, dig constructor, build.list.reduce. Okay, so one thing we want to know is, did we find a type, right?
Yeah. And in fact, it might be interesting to like where we're digging everything out above there.
Yeah.
Yeah. So like basically all this, maybe add a AAA to all of this stuff. Yeah. Okay. Yeah. And now we can see if we found a type as well.
Yeah. Type contents kind. Interesting. I wonder what the kind is. I wonder if we could show that. Looking for Gandalf. Found it.
Ooh.
Gandalf.
All right. So that's, I guess, the identifier that it found.
Now, is that looking for Sean? Found it, Sean. So they're behaving
Yeah.
properly so far. So when it found it, that means that it found Gandalf in scopes. And then it wants to get the constructor path for the type. And it wants to get the type right there. And if we could derive the name of the type, but with loc string, then we could print it.
Yeah, that should be easy enough. Oh, I mean, we can just destruct it. It's not that difficult. So if we just add another logging line after 602.
Okay.
And we can just do log AAA. And then let's just call it type name, I guess.
Okay.
Yeah, and then sure, and then and then we'll just call it type name, and then the line above it we'll do another let binding. So we can just say let location.log.
Let type name equals.
No. So we're going to destruct it in line.
You might have to teach me how to do that.
Okay, so delete this line.
Okay.
And hover over type on or tip on 601. Copy that name. So see name is location.log string. So just copy that.
Okay.
And now do let and paste it in. And then equals tip.name. And so now what we've done is we've destructured that. And so string is going to hold that type name. And so let's just call that type name.
I didn't know you could destructure without a switch.
Yeah.
What happens if you...
Well, so the thing is, if it's a switch and you destructure like a none and a sum or whatever, and if you do that in a let, it's going to say, hey, you're destructuring, but you're missing the other case.
Right.
But in this case, there can only be one case. So it's okay. It's cool for us to just pull out that one thing.
So is that because loc is an opaque type, essentially?
No, it's just not a variant. It's just a parameterized type.
Yeah. Yes. But without like a name field or something. Like we can't get the name field out.
No, we could if we want to.
Oh, okay. As long as we knew the shape of the field.
Yeah.
Why are we getting a syntax error here?
Well, maybe I've led you astray. Maybe it won't work. We'll see. Yeah, maybe I've led you astray. Can you hover over on tip again? This is probably my fault.
Right. Where did tip go? There it is.
Yeah, so we'll just need to comment this out so that our tools kick back in. And so location.log, so loc is parameterized by a string. Can we do, so we can do a little bit of force hacking. Like this is a little trick I use.
Okay.
If you copy that location.log string again, and we're going to do another let binding and just say let x colon and then paste in that definition and equals 0.
This is like force type hints.
Yeah, and it's like, hey, this is wrong. So now if you hover over X, well, I guess it's not going to work then.
So we need the location type, essentially.
Yeah. Like I want to know what's inside of there.
There it is, because I can't inspect that. I can't command click on it. It's type T, warnings.loc, loc start, loc end, ghosts. So it's not parameterized.
Yeah, so it might be a different loc, like you said. Is that something that Jared made?
I don't think so.
I mean, you could search for type loc, open parenthesis.
Or even a module location. Nothing.
Okay, so it looks like it probably is coming from OCaml then.
Using location module, OCaml location. Oh, you know what? Type loc. There's no type loc. This is insanity.
Yeah. Okay, well, what we were trying to do is, well, I guess actually we can just like leave this out and get a list of like whatever it has, right?
Well, we were trying to find the type name, right? Because we wanted to see if it was actually getting the type of the record of the object.
Okay, what else is in tip that we might be able to pull out that would tell us?
There's the doc string. Let's see. Module path exported docstring contents. See, it's surprising to me that we have location.loc and location.t. Because I know there's like type loc. I thought there was a type loc in here.
And you don't have any autocomplete in this project, right?
I do. I have it when it's working.
So can we see what's inside of the location module then? So if we do like location dot,
there's no.
I mean just.
Oh, you mean just typing it?
Yeah.
Well, we don't have it now. Shared types. There's shared types.loc with an uppercase L. That's what I was talking to.
Got it. Okay. Yeah.
Well, let's make a note about where we are, and then we have to come back to it later because I have to get to the DMB before it closes.
That's probably a good idea.
So we were trying to figure out what the type of the argument is here. On Gandalf. I'm going to come back after and keep hacking on this, and you may or may not want to join me depending on your schedule and patience level. But
yeah, feel free to ping me. I actually have a bunch of tools that I built for this stuff. Yeah, I have a location.loc here actually. Yeah, so I can take a look at this and yeah, awesome. Ping me whenever you're back.
Do you want me to push up progress?
No, I'm not gonna. I have other stuff I'm working on.
Great.
Definitely not gonna try to get this working.
Okay, great. All right, thanks, Sean.
All right, cheers. I'll talk to you soon, hopefully.
Okay, see ya.
All right, bye.